So here I'm going to continue kind of off the end of that other video. This program is slightly different, has some more code added onto it, but before I had done this, I added the contents of the array, searched the array, finding the maximum number and finding the index. This is from the basic array source file. It should be under week6, week6.zip. Under D2L, you should be able to download it. And I put my breakpoint here, and I've actually already ran it. So I've entered the debugger, ran it to stop at this line here. Here's my array that I've loaded up before. I've kind of put the array contents over here just in a slightly easier way to see it. 2 and 3. So what I want to do, and I'll print it out here real quick, just get to the next part here. So there you can see 6, 7, 2, 3. Now I want to do a left shift. And so left shift in most digital applications means if I take this array as it's defined, that means if I left shift one position, I want this to be 7, 2, 3, and then feed in a 0 from over there. Now to do a shift, a left shift means that I need to copy or manipulate or move these numbers around. So if I look at this to this, a left shift means why don't I start and I'm just doing one position at a time, so I'm not worrying about am I left shifting 2 or 3 places, just one position. The 6 goes away. You can see from here the 6 just kind of disappears, and that's how we've defined a left shift. But that means that the next one down simply is copied over. And so we copy the 7 into this index, we copy the 2 into here, we copy the 3 into here, and then fill the rest with 0. So that's why the 7 moved over 1, the 2 got moved over, the 3 got moved over, and we have a 0. So I'll start that out. I'll go walk my way down from the highest index, and that's why in my setup for my for loop here, I've set for index equals array size minus 1. Array size would give me this, and I want to go down one more. So let's go in here. So lower index, I got to keep track of the next position down, and we'll go in. All right, now we're gonna first, before we do the copy, we're gonna decrement the lower index. That's 2, and I'm gonna take the current index, which is 3, go look in the second index, index 2, and just move it. And so you'll see the 7 kind of fly into the 6 there. And the original 7 is still there. I'm going to take care of that in a second. Hit the end of the for loop. Keep going because I'm within the range. And decrement that. Now you'll see the 2 fly over. And we'll go back and we'll do let's see, there's the 3. Now it skipped. You notice I didn't go all the way down. I didn't hit this last index. I stopped at 1 because I'm only shifting one position, so I could leave this empty. And then this last line here, I'm filling up that last position with a 0, and I'll hit next. And there you can see 0, 3, 2, 7. And I'll hit that last next line, and there it's printed out just like we saw over here. Now on the programming assignment number 3, you're going to first do a right shift, which is going the other direction, so you'll be walking your way from the bottom of the array up, and then extend that into a method where you can actually shift any number of, right, function where you can shift any number of positions. Now this last little bit, just to explain what this is, just a little fun thing. Let's actually, I think I'm gonna put my breakpoint down here and run it, and up there. All I got is this little fun thing that's simply looping 10,000 times. There's a new thing that we introduced here, and there's a little bit of a delay in there as well to slow it down, but the system CLS, so all that does is clear the screen. So what's really happening is this is there's a counter here, really just a counter, taking the remainder, and then if it's a 0, printing that out, printing a 1, if it's 1, printing that out, and 3. So it's going to cycle continuously between these three things. You can kind of see that over here. It looks like it's moving. That's just because it's going fast. Here is this is just a time delay. If I didn't have this time delay, it would just go too fast. And this last part here is its CLS stands for clear the screen. So it prints out first this line, waits, clears the screen, prints out this line, waits, clears the screen, and keeps doing that. Well, it'll eventually stop, but for quite a while. And if you want to use a system CLS to clear your screen, you have to include this include C standard lib, and that lets you tidy up your output if you want with a clear screen.